Hey everyone, and welcome to Adeptis Academy. Have you ever looked at lines of code and felt a mixture of awe and intimidation? Like some strange, indecipherable language was whispering secrets right in front of you? Well, you're not alone. Today, we're diving headfirst into the fascinating world of programming languages. Understanding different programming languages is like having a toolbox full of specialized tools. You wouldn't use a hammer to tighten a screw, would you? Similarly, each programming language has its own strengths and is best suited for specific tasks. Whether you're interested in web development, data science, or even just satisfying your curiosity, knowing the basics can open up a whole new world of possibilities. So, if you're ready to demystify the language of computers, buckle up. In this video, we'll be exploring the fundamental concepts of programming languages and learning how to read them. Don't forget to turn on subtitles and let's get started. So let's address the elephant in the room, or should I say, the compiler in the computer. What exactly a programming language? In the simplest terms, it's a way for us humans to communicate with computers. You see, computers think in binary code, a series of zeros and ones, which is pretty hard for us to understand, let alone write. That's where programming languages come in. They act as translators, converting our human-readable instructions into that machine-understandable binary code. Think of it like this. Imagine you want to order a pizza, but the only way to do it is by sending a series of beeps and boops through a telegraph. These languages provide us with a set of rules and keywords that we can use to write instructions, known as code. This code tells the computer what to do, step by step. Just like any language, there are different dialects, each with its own syntax, grammar, and areas of expertise. Some languages, like Python, are known for their readability and beginner-friendliness, while others, like C++, are more complex but offer greater control over the hardware. The choice of which language to learn depends on what you want to achieve. Do you want to build websites, develop mobile apps, analyze data? There's a language out there for every purpose. So, whether you're a complete beginner or have dabbled in coding before, I encourage you to stick around. We're about to embark on a journey that will unlock the secrets of programming languages and empower you to communicate with computers in a whole new way. Now that we've got a handle on what programming languages are, let's talk about how they're classified. One of the most fundamental distinctions is between high-level and low-level languages. No, this isn't some kind of computer caste system. It's more about how close the language is to the ones and zeros that computers understand. Think of it like this. Imagine you're trying to give someone directions. You could either give them detailed step-by-step instructions on every turn, every landmark, every traffic light. That's like a low-level language. Or you could just tell them, hey, head to this address and let their GPS figure out the rest. That's a high-level language. Low-level languages, like assembly language, are as close as you can get to talking directly to the hardware. They give you a lot of control over how the computer uses its resources, but they're also incredibly complex and time-consuming to write. It's like trying to assemble a car engine by hand. You need to know exactly what every nut and bolt does. High-level languages, on the other hand, are designed to be more user-friendly. They use simpler syntax and abstract away a lot of the complexities of the underlying hardware. This makes them faster and easier to write, but you sacrifice some of that fine-grained control. It's like driving an automatic car. You don't need to worry about changing gears, but you also can't fine-tune the engine's performance. So, which type of language is better? Well, it depends on what you're trying to achieve. If you're writing an operating system or a high-performance game engine, you'll probably need the power and flexibility of a low-level language. But for most everyday programming tasks, like web development or data analysis, high-level languages are the way to go. They allow you to focus on solving problems and building applications without getting bogged down in the nitty-gritty details of how the computer works. The important thing is to choose the right tool for the job. And that's what makes understanding the difference between high-level and low-level languages so important. All right, now that we've covered the basics of programming languages and their classifications, let's dive into some specific programming paradigms, or ways of thinking about and structuring your code. One of the earliest and most common paradigms is procedural programming. Imagine you're baking a cake. You wouldn't just throw all the ingredients in a bowl at once and hope for the best, would you? No, you'd follow a recipe, a step-by-step guide that tells you what to do and when to do it. That's essentially what procedural programming is all about. breaking down a problem into a sequence of procedures or functions that are executed one after the other. Each procedure is like a mini program, a self-contained block of code that performs a specific task. For example, you might have a procedure to mix the batter, another to bake the cake, and another to frost it. By dividing the program into these smaller, more manageable chunks, procedural programming makes your code easier to read, understand, and maintain. Procedural programming languages like C and Pascal were incredibly popular in the early days of computing, and they're still widely used today for tasks where efficiency and control are paramount. They're like the trusty hand mixers of the programming world, reliable, straightforward, and great for getting the job done. However, as software became more complex, procedural programming began to show its limitations. One of the main drawbacks is that it can lead to what's known as spaghetti code, a tangled mess of procedures that jump all over the place, making it difficult to follow the flow of the program. To address these limitations, newer programming paradigms like object-oriented programming emerged. For now, just remember that procedural programming is all about breaking down problems into smaller, reusable procedures that are executed in a specific order. All right, folks, buckle up because we're about to enter the world of object-oriented programming, or OOP for short. Now, if procedural programming was all about following recipes step by step, OOP is like organizing a zoo. Hear me out, it'll make sense in a minute. In OOP, instead of just thinking about procedures, we think about objects. An object is like a self-contained unit that combines both data and the actions that can be performed on that data. Think of a lion at the zoo. The lion itself is the object. It has data associated with it, like its name, age, weight, and so on. But it also has actions it can perform, like roaring, sleeping, or hunting. In OOP, we call these actions methods. So a lion object might have methods like roar, sleep, or hunt. These methods are like the verbs that describe what the object can do. And just like in a zoo, where you have different types of animals, in OOP you have different types of objects, each with its own unique set of data and methods. For example, you might have a tiger object, which would also have data like name, age, and weight, but its roar method might sound different from the lion's roar. OOP allows us to create these reusable blueprints for objects called classes. A class is like a template or a cookie cutter that defines the structure and behavior of an object. So, you could have a lion class that defines the data and methods that all lion objects will have. Then, you can create individual lion objects based on that class, each with its own unique data values. This makes OOP incredibly powerful for managing complex software projects. Instead of having a huge, tangled mess of procedures, you have these neat, organized objects that interact with each other. Some popular OOP languages include Java, Python, and C++. They're used in a wide range of applications, from web development to game development to mobile apps. Hold on to your hats, code enthusiasts, because we're about to enter the realm of functional programming, a paradigm that might just change the way you think about writing code. If procedural programming was like following a recipe and object-oriented programming was like organizing a zoo, then functional programming is like building with Legos. In functional programming, functions are king. They're treated as first-class citizens, meaning they can be passed around as arguments to other functions, returned from functions, and even stored in variables. It's like having Lego blocks that you can snap together in countless ways to create complex structures. But here's the kicker. In functional programming, functions are pure. What does that mean? Well, it means that they always produce the same output for the same input, and they have no side effects. In other words, they don't change anything outside of their own little world. This emphasis on pure functions and immutability, meaning data can't be changed after it's created, makes functional programming particularly well-suited for tasks involving data processing, parallel computing, and writing concurrent programs. Some popular functional programming languages include Haskell, Lisp, and Clojure. It's like building a Lego masterpiece. The possibilities are endless. So, if you're up for a challenge and want to explore a paradigm that's both powerful and intellectually stimulating, functional programming is definitely worth checking out. And there you have it, a whirlwind tour of the fascinating world of programming languages. We've covered a lot of ground, from the fundamental differences between high-level and low-level languages to the intricacies of procedural, object-oriented, and functional programming paradigms. Remember, this is just the tip of the iceberg. There's a vast and ever-evolving landscape of programming languages out there, each with its own strengths and quirks. I encourage you to explore further, experiment with different languages, and discover which ones resonate with you. Thank you so much for joining me on this coding adventure. If you enjoyed this video, please give it a thumbs up. Leave a comment down below, and don't forget to subscribe for more exciting explorations into the world of science, technology, and beyond. Until next time, happy coding!